Here's our same direction travel example. I kind of like to think of these problems as the catch-up problems because you have two people leaving at different times and traveling in the same direction, and one of them is catching up to the other one. So we have a moving van, which leaves the house traveling at an average rate of 40 miles per hour, and then the family leaves half an hour later following the same route in a car. They travel 60 miles per hour. How long will it take the car to catch up to the van? So I've already defined my variables in step 1. I have x representing the time in hours that it will take the van to get to the point where the van and the car have caught up to each other. And then I have defined my variable for the car's time, as x minus 0.5, or that would be the same as x minus 1/2. And the reason I have x minus 1/2 is because the car is leaving half an hour after the van. So by the time they catch up to each other, the car will have traveled for half an hour less than the van. And remember, there's a reason why we're not using x minus 30 if you were thinking 30 minutes later, because the rate that we're given is in miles per hour. So you want to define your variables in that same way. And then we can start filling in the table. The rate of the van is 40 miles per hour. The rate of the car is 60 miles per hour. The time is going to be right here where we defined our variables. So the time in hours for the van is x. The time in hours for the car is x minus 1/2. And then again we multiply rate times time, and that equals distance. So 40 times x is 40x, and 60 is going to be distributed to x minus 1/2. So that gives us 60x minus half of 60 is 30. And now is when we set up our equation, and this is when it's important to think of this problem as a catch-up problem. And in step 3, when we write the equation, we set these two distances equal to each other. So they're not adding up to some total amount, they're equal to each other. There we go. And then we can solve our equation. So we get x equals negative over a negative is a positive. 30 over 20 reduces to 3/2. And that's the same as 1.5. So if we multiplied 40 times 1.5, if we went up here and checked our answer, 40 times 1.5 is 60. And remember, the car is traveling for half an hour less. So if x is 1.5, then x minus 1/2 is 1. And 60 times 1 is also 60. So they both traveled 60 miles, so the car has caught up to the van. And then we have to answer the question. Find the time the car travels. So the car, which is traveling x minus 1/2, that's 1.5 minus 1/2, which is 1 hour.